All right, good evening, this is Professor Dan Steffi. It is 8:30, so go time. All right, so this is week 3 of your 102 course in Python. So kind of what I do here is I'll go over the material that you need to know for this week. Then I will discuss some things that will help you out with the assignment, and then I will open it up for questions and answers. If at any point I'm going over something or talking about something that you don't quite understand, feel free to speak up or put a message in the chat and ask me to explain it further. Okay, so a lot of this week's material was talking about Boolean expressions and conditional execution. And what I mean by that is your if, your else, your elif, those type of things, and logical operators and test cases. So let's go ahead and dig into some code talking about each one of those. So first thing we have is Boolean expressions. What I mean by a Boolean expression is you are doing some kind of mathematical comparison to determine, is something less than something else, is a value greater than another value, are they equal to each other or are they not equal to each other? So let's start off by saying, let's just say print true. Oops, let me get my keyboard working. Print true. So what's going to happen here? So there's two built-in values in Python. One is true and the other is false. It just tells us is this expression true or is this expression false. So if we have just print true here, and if we run this, file, it just prints true. And obviously, because we told it just to print true. Conversely, we can have it print false, right? And it prints false. Now, where it becomes more interesting is you can put mathematical expressions in here. So let's say print 3 is greater than 2. That should print true, right? Because 3 is greater than 2. So if we print 3 is greater than 2, it prints true. 3 less than 2, save it and run it. And of course, it prints false. So that's the less than or equal then. We can also have, is it equal to, meaning is 3 equal to 2? Should be false. Just false. 3 is not 2. Is 3 equal to 3? Save it, run it. That's true. 3 is equal to 3. And then we have not equal to. Is 3 not equal to 3? That should be false. And it is. If we put 3 is not equal to 5, that will be true because 3 is not equal to 5. And it is true. So how does this help us? Well, we can do, well, actually, before I get there, we can also use it with variables. So if I had to say x is 5, and here I can say print x equal to 5. This should be true, right? Because I'm making x equal to the value 5, and I'm saying print out is x equal to 5, and that should be true. It is. And of course, I can do the not equal here, and so on and so forth. It becomes false. I can also check that with user input, right? Let's say I want the user to enter in a value. I want it to be an integer. Let's just say, enter a number. And then we're going to say, is that number equal to 5? So what am I doing here? I'm getting input from the user. This is the prompt I'm giving them. I'm going to turn that input into an integer, and I'm going to make x equal to that integer. So we're going to say, have the user input a number and see if that number is equal to 5. So let's run it. Enter a number, say 1. It prints false because I entered 1, and 1 equals 5. No, that's false. So it prints false. I can run it again. If I type in 5 this time, it is true. I typed in 5, x is 5. Then I print is x equal to 5, and that is true. So how does this help us? We have the conditional execution. Oops, let's actually bring that back. So I'm still going to have the user enter a number. But let's say if the number, just speaking in English, just think of things logically. Let's say if the number is less than 5, I want to do something. If it's greater than 5, do something else. So what's that look like in Python? We can say if the variable is less than 5. And we end it with a colon. And then we tab in. Whenever you have these conditional statements, the tab is very, very important in Python. That means if this is true, I want to do this. Do this. Oops, that's my comment. Do this. Do this. How many ever things I want to do. And now this is after the conditional. What I mean by that is each one of these that's indented, these will only execute if this ends up being true. So if x is less than 5, all of this will happen. If x is not less than 5, then everything here gets skipped, and it just goes down here after the conditional. So how we'll see that, let's say print after the condition, if I could spell it, conditional. And then in here, we'll just do one thing. We'll say print inside the conditional. And that'll tell us where we're at. So this will let the user type in a number. If that number is less than 5, it's going to print this. And then after the loop, after this conditional, it's just going to print after the conditional. So let's run it. So what's going to happen if we type in a 1? If we type in a 1 here, that means x will be 1. If 1 is less than 5, that is true. It'll print this out. And then afterwards, it'll print out after the conditional. And that's because if this is true, it prints out this. But since things are no longer indented, this just resumes normal execution here. So let's see what happens. Enter a number, enter 1. We are inside the conditional, and then it's after the conditional. And that's because 1 was less than 5. Let's type in 5. What will happen? X will be 5. 5 less than 5, that is false. 5 is equal to 5. 5 is less than or equal to 5, but 5 is not less than 5. So this is going to be false. So it'll completely skip any of this indented statements. So let's run it. And of course, the only thing we see is after the conditional. And that's because this was false, so it skipped all the indented statements and went directly afterwards to this. So that's how if works. You have some kind of mathematical comparison here. You can have it less than, you can have less than equal to, you can have greater than equal to, you can have equal to, and you can have not equal to. So let's do not equal to. So if x is not 5, print that out. So if we run it, if we type in 5, it doesn't print inside the conditional. If we type anything other than 5, it's inside the conditional, because the check we made is that number not equal to 5. So that's our condition. That's part of our conditional execution. For simplicity, let's just change this back to less than. And inside here we'll say, number is less than 5. We can do else. That means if this is true, these statements get executed. If this is false, whatever is under the else gets executed. So we can print number is 5 or greater. And why is that or greater? Because here we're saying, is the number less than 5? If it is true, it prints that out, and then it skips the else. So what can make this false if x is 5, 6, 7, 8, so on and so forth through infinity, right? If x is 5 or any number greater than 5, this will be false. So it'll skip this and it'll execute the else statement. So let's run that, save it, run it. So if we type in 1, the number is less than 5. If we type in 66, 6666666, number is 5 or greater. If we type in exactly 5, number is 5 or greater. If we do 5.1, well, it's an error. Well, then the error is because I said it was an integer, and I typed in a float. I can make this a float. Let's run it. Now if I do 5.1, the number is 5 or greater, and it is. I can run 4.9, number is less than 5. So there's a third kind of conditional check we can make. It's called an elif. And it stands for else if. So what will happen, it'll do this check. If this check is true, it executes this and skips the rest. If this is false, it'll do this check. Let's say x is greater than 5. Print number is greater than 5. So if this is true, this is executed, everything else is skipped. If this is false, it goes to the elif and kind of repeats that process. If this is true, this is executed. If this is false, then it'll go to the else statement. And what do we know if it gets to this else statement? So here it checked, is the number less than 5? Here it checked, is it greater than 5? So the only way you can get here is if it is exactly 5. Number is 5, right? Let's make this back to an integer so we're not looking at floats anymore. So let's run this. If we type in 1, the number is less than 5. Type in 4, the number is less than 5. Type in 6, the number is greater than 5. What happens when we type in 5? The number is 5. And that's a result of these conditional checks. Checking the value that the user input against each of these different values. So that's how the if, the else if, and the else statements work. And it doesn't have to be just one thing. You know, you can print something else. Let's copy the string so we know where we're at. Numbers less than 5, more, you know, whatever. Just so you can see that it'll print out both of these statements. And that's because of the indentation. The indentation represents the block of code that'll get executed depending on if this condition is met. So you're not just limited to one statement. It can be as many statements as you want as long as they follow the indentation pattern. So let's just run it just one time. Put in 4. Number is less than 5. Number is less than 5. Number is less than 5 more. Just because it executed those two printed strings. Okay. So that's our conditional execution. Talk about one more thing from the material, and then we'll look at the assignment. So let's talk about test cases for a minute. Okay. So over the past, for last week's assignment, didn't really grade too harshly on test cases or anything like that. But in week 3, it presents to you what a test case should actually look like, right? So what should a test case look like? Let me see if I have some kind of notepad on here. I think I have leaf pad. If I could get a text editor open, programming. No, I'll just use this as a text editor. Be fine. Okay. So, make this in your Word document to make it look nicer. Make a table in a Word document or PDF, whichever the case is you want to use. What should a test table look like? You should have various columns in it, right? And this is just regurgitating what is in the course content. So look over it more thoroughly. But your test table should have something like case number. Let's make this a little bit smaller. Yeah, that's good. Case number as one column. Then it should have input. Then it should have expected output. Then it should have actual output. And then it should have pass or fail. Put some more spacing in here. All right, that should be the columns for your test cases. So let's say, for example, my program just added two numbers together and printed the result, right? So I'll just do a little program down here, but we're not going to run it. So we'll have A equals the integer, the input. Just tell the user to enter a number, right? And then we'll have the user enter two numbers, right? This has the user enter two numbers, A and B. Let's say C equals A plus B. And then we'll print out what C is, right? Real short program. User enters a number, stores it in A. User enters a number, stores it in B. We add them together, and then we print the result, right? So what does a test case look like for this? Well, we have the test case is 1. If we put input into this program, let's say the input we're testing, say, is 2 and 3, right? They enter 2 for the first number and 3 for the second number. What is the expected output for that? The expected output, if they're added together, is 5, right? Now, it is extremely important that your expected output is something that you manually calculate, right? Actually, let's show you why. We will actually run this program. So let's take this program, put it in my Python file, and save it, okay? So let's think about this expected output. We're expecting it to just add two numbers together, right? So if this is the input, we can take our calculator and figure out what they are added together, and that's 5, right? This expected output must be manually calculated. It should not be, you should not run your program, see what it prints, and then have it as the expected output. And you'll see why in a second. When I say manually calculated, yeah, you can use a calculator, that's fine. I'm not saying do it with pen and paper, right? But I'm saying do not use your program to figure out what the expected output is. Okay, so what is the actual output our program produces? Well, to do that, we need to actually run our program with the input of 2 and 3. So let's run our program, input 2, input 3. The output is 5. That's the actual output from our program. And pass or fail. Is the expected output the same as the actual output? This passes, right? Let's do one more, and then we'll throw a wrench in it. So for case 2, let's say the input is 5 and 3. What do we expect it to produce? We expect it to produce an 8 because that is 5 plus 3. Let's see what the actual output of our program is if we put in 5 and 3. Let's run it. Put in 5, put in 3. It produces an 8 as the actual output. That passes, right? Let's make one more test case. Let's say the input is 4 and 7. What do we expect the output to be? We expect the output to be 11, right? What is the actual output? Well, let's say we made a mistake in our program, okay? Let's say instead of add, it's subtract. You know, our program was to add two numbers. numbers together, but when we programmed it, we made a mistake. Instead of putting a plus there, we put a minus. We made a mistake in the program. That's real easy to spot right here because, you know, it's only 4 lines long. But if your program is 1,000,000 lines long, it'll be a lot harder to spot errors, right? And that's the point of test cases. So let's say our program was to add 2 numbers together. We made a mistake and put subtraction instead of addition. So let's go to our test case. Test case number 3, if our input is 4 and 7, we expect the answer to be 11. What is the actual output? We run this, let's say 4 and 7. The output is -3. So when we put this here, -3, we have now failed a test case, right? And this should be a red flag. The reason why it's a red flag is because something went wrong in our program. Our program is incorrect. We know that because we expected it to give us this value. It actually gave us this value. So something's wrong with the program. Our test case failed. When you have a failed test case, it's an indication something in your program is wrong and you need to go back and fix it. Whenever you turn in, you know, these test cases as part of your assignments, I really should never see anything that says fail here. And that's because, like I said, if it failed, your program is wrong and you need to go fix it. Okay, so we see this, we see it failed, and we think, okay, well, we need to go fix it. We look back at our code and we go, oh, of course, you know, this should have been a plus. Let's run that test case again. 4, 7. It gives us the answer 11 this time. Oh, okay. That's the right answer. It doesn't fail anymore, it now passes. And that's the point of test cases, is to catch errors in your program, to find where you did things wrong. What I do not want to see, and I will take every point away from you on test cases, is if you do something like this. Let's say we made an error in our program. Okay, we're supposed to add 2 numbers together. We accidentally multiplied instead of added. Let's just look at one test case. So if you give me something like this, let's say 2 and 3, we know the expected output should be 5, right? Because we're supposed to add. But let's say you put the expected output as 6, actual output 6, pass or fail. Oh, it passed, right? This is clearly incorrect. That's because, you know, if we're adding numbers together, we know that 2 plus 3 is not 6. We know that's wrong. So whenever I look at test cases turned in like this, I instantly know what you've done, to be honest. I'll see not a lot, this happens, it doesn't happen often, but it happens, is I'll have students turn this in. And it'll make me think, you know, 2 plus 3 does not equal 6. What they have done is, instead of manually computing what the expected output should have been, they just ran their program, 2, 3. Oh, it puts out 6. So let me just put 6 for the expected output and the actual output, and it passes. As again, like I said, that's clearly wrong. Expected output needs to be manually computed with the calculator, that's fine. But you shouldn't just copy what your program outputs into the expected output in case your program is wrong. So look over more at the test cases and that table in this week's reading, but make sure you're using that format for all the test cases for the future assignments. Okay, enough about test cases. Last thing I'll talk about is the assignment. I will kind of do a little bit of coding of something similar to your assignment, not exact, but similar to your assignment. And then we'll open up for questions and answers. Okay, so for your assignment, you have to do some computation about the price of a theater ticket, right? Okay. Let's do something similar. Let's say we want to compute the cost of a rental car. Okay. So let's have it be cost. So we'll say the cost starts out being 0. So what is the cost of a rental car based on? We will use 2 factors. One is how old you are, because if you go get a rental car, I think if you're over 24, it becomes cheaper for whatever reason. If you're less than 24 years old, it's more expensive. Okay. And, what kind of car do you get? Did you get a fancy car or a standard car, right? Your little Ford Fiesta is going to be cheaper to rent than, a Tesla, right? So let's start off with the cost being 0. So we need to ask the user how old they are, because the cost will depend on how old they are. So we'll say age equals the input, enter your age. So what's going to happen here? We're going to have the user input at the keyboard their age. We're going to store it as an integer in this variable. So age is now how old the person is. Okay? Actually, let's do that part second. Talk about the age. First, we'll ask them, what kind of car do you want? We'll say kind is equal to input. What kind of car? And I'll tell them, not care, but car. They can either have a fancy or standard. Yeah. That'll be the prompt. Okay. So the kind will be, what kind of car do they want to do? A fancy car or do they want a standard car? And let's see. Just print these out so far. We'll print out the kind and we'll print out the age. Oops. So the kind will be what they type in for what kind of car, and the age will be how old they entered that they were. Let's save it. Let's run it. Just see what happens. What kind of car, fancy or standard? Let's just say it's a fancy car. And enter my age. Don't worry about how old I am. And there you go. We typed in fancy for the kind of car, and we typed in that for the age. Okay. So now we need to take that information and compute the cost of a car out of it. So we need to determine what kind of car they want. If kind is equal to fancy, do this. Else, if kind is equal to standard, do this. Else, do this. So what we're doing here, if what they type in is fancy, we'll do this. We'll say the cost is $1,000 for a fancy car. If it's a standard, the cost will be $750. That's an expensive rental. Else, so how would we get to else? If they typed in something that doesn't match fancy and it doesn't match standard, it's going to get here. So if they typed in Ford, it's going to end up at the else. If they type in anything except these exact strings, it'll get here. Even if they, they fat finger it, let's say they put FANY and left out the C. It doesn't match this. It doesn't match this, so we'll get to else. So if it's else, it'll kind of be our catch-all, and it'll be $500. So don't worry about the kind and age. Let's just print out the cost so far. So we save it and run it. Let's put where we can see the code. So what kind of car, fancy or standard? If we put fancy and enter my age, the cost is $1,000. And that's fine because we typed in fancy and that made the cost $1,000. So if we type in standard, enter my age, and that's fine. the cost is $750. And that makes sense because kind is standard, which matches right here and makes the cost $750. Now, if we type in anything else, then it's $500 because anything else does not match that string, so it gets caught up in this kind of catch-all. Like I said, it also goes if you fat finger it, FANC, when we forgot the Y. And it's still $500 because FANC, it does not match that entire string, okay? So that's how we can get the cost based on what kind of car they input. Now we need to consider the age, right? So how's age factor in? You know, I said if you're 24 years or older, then a rental car is cheaper than if you are less than 24. So let's just say if you are 24 or older, this is the cost. There's nothing additional. However, if you are less than 24 years old, let's say there's a 25% extra fee on top of it. So how would we check that? We say if the age, that's how old they said they were, the age is less than 24, do this. And so if we wanted to incur, you know, like a 25% additional charge, how do we do that? Well, we're checking if their age is less than 24, we want to incur the extra 25% charge. So we have cost equals cost plus cost times 0.25. And this is just some math stuff. This is just saying, this is the 25%, and this is adding the 25. This is adding the cost plus the 25% cost and saving it as cost. Print cost. You could also do this like cost equals cost times 1.25. And I'm not teaching a math class, so that's the math for a 25% charge. We'll print the cost. So let's run this. Let's say they want a fancy car and they're 55 years old. The cost is $1,000, and that makes sense because we've got a fancy car for this cost. Their age was not less than 24. This is false, so it skips that surcharge. All right. Let's get a fancy car, and they are 23 years old. There. The cost is now $1,250. That's because they got a fancy car for this cost. 23 is less than 24. That's true. So then they added on that 25% surcharge, and then we printed out the cost. One more run through. They got a standard car, and they are 24. It's still $750. They got a standard car, and they're 21 years old. It's a little bit more expensive. So this is very close to what you need to do for your assignment. It's not exact. I'm not going to give you solutions to assignments, but it's pretty close to what you need to do for your assignment. All right, so I will go ahead and open it up for questions and answers. You can ask anything about this week or previous weeks, or even anything coming up in future weeks. So the floor is open.
Hey, Professor, this is Will. Can you hear me?
Yep, I can hear you.
All right, so I have a quick question, I guess, in regards to this week. Does there have to be any kind of evaluations or like within the code or any kind of computations for this assignment? As long as we have like the if, elif, and else down, should that be good enough? Like the way that I did it, I didn't actually have any math happen other than the math I did in my head. And to display, I don't know, it's hard to explain what I did, but it works the way it's supposed to work, but it doesn't involve any kind of computations within the code. Is that all right?
Yeah, I understand what you're saying because believe me, I've done this class plenty of times and I've seen the code worked up in so many different ways. I mentally understand how you went about it, and that's perfectly fine. I mean, the assignment does not say do
To
math
do math.
do math computations to figure this out. As long
Right.
as your program basically follows the specifications, it meets if it does what the assignment tells you to do, then you'll be fine. As long as it gives the correct answer, then it'll be fine.
Copy. All right. Just making sure, because I was like, oh man, I didn't use math. I did static terms, right? Static. So anyway, I appreciate it.
Good evening, Professor.
Yep, I can hear you. Go ahead.
Just a question. I've been trying to focus on preventing Python from crashing when input that is entered in by the user is incorrect. So like if the input is expected to be an integer and the user inputs a string or a float, I've been having a hard time, creating all the what ifs and like the if and elifs code to make it like precisely the exact input that I want it to be specified. Because I know if it asks for a yes or a no and they put sure, then the program would crash, and I'm just trying to make it work a little bit better so that the program only ends when the user chooses to end the program, or if the program runs efficiently all the way through like it's supposed to until it gets the answer, if that makes sense.
Yep. I'll preface this by saying there's nothing in this class at this level that requires you to validate user input. So if the user inputs something, like if they input a string when you expect an integer, I'm not going to count off if you do not check to make sure it's a valid input for this class. But I will go ahead and show you how to do that check if you want to add it in there. I mean, in a finished real world production code, you absolutely have to take those things into account. So I'll quickly show you how to do that. It hits on a couple of concepts that are in future weeks, but you can go ahead and see kind of what it looks like. So let's take, for example, in my example program here, I'm having the user input their age as an integer, right? So you're absolutely right. If I try to run this and I put in a fancy car, enter my age, and I put QWERTY, and it crashes. So as you're saying, how can I make sure they actually input an age? Well, we have to employ loops. And loops will be introduced in a week or two further in the class, but I'll go ahead and give you a quick preview. So we need to repeat the same code over and over and over again until the user does what we want them to do. So there's a loop called while. And for this example, we can just put true. This is kind of like an if-else statement. But with an if statement, it says if this matches, do this, and then skip to the after the if-else statement. The while statement means it executes this piece of code over and over and over and over and over again forever, as long as this remains true. And since I've used the word true, this will always be true. So this right here will never terminate. It'll just keep asking you for your age forever and ever. I'll show you that real quick. What kind of car, fancy car. What's your age? 4. What's your age? 23. What's your age? What's your age? What's your age? Blah, et cetera, et cetera. So you see how it just does this loop repeatedly with no end. It does, however, crash if you put in a string. So inside here, we need to check, is it valid input or not? So there's this other word called try. What this means is, let's see, try and accept. Yeah. What I'm saying here is try to do this. There is a chance it will fail. That's what you're saying here. So try to do this. So if it does fail, it'll execute whatever is in accept. So let's say just print it failed, just so we can see it print out on the key, on the screen. So let's just run this and see what happens. So we run this, kind of car, doesn't matter what kind of car, enter your age, 12, 56, 70, it's fine. What happens when we type in a string? It just print, it failed, right? But it's still stuck in this loop. So what we need to do, we need to figure out a way, how can we stop this loop if it is a valid age? And what we have here, we have a word called break. What that means is, if I get to this break, whatever loop I'm in, get out of the loop. So if I type in an age that is an error, it'll immediately go to this accept. It failed, starts the loop back over again. But if the age is a valid input, it'll just go to the next line. It'll execute this break, and the break means stop, get out of this loop, and it'll continue with the rest of the program. So let's see that in action. Oops. Let's save the file. Oh, great. I can't even get out of, there we go. All right, so let's run it. Kind of car, fancy car, enter my age. Let's enter some invalid ages. It failed, keeps asking me my age, it failed. Enter a valid age, and it continued on with the program, right? So this is future weeks stuff, but this is how you can validate that what they type in is actually valid user input.
Thank you for showing me the those words. I was trying to use mainly like if, elif, and else, along with trying out the while. I know it's going to be covered in a couple weeks ahead, so I'll try not to get too far ahead, and I'm sure it will be answered later on.
Yep, it's fine. And like I said, there is no requirement in this class to check valid user input. You'll have to do that in future classes, rest assured. But if you want to add it in your programs, I have no problem with that.
Okay, thank you, Professor.
Hey, Professor, this is Will again. Let's say, for example, we use some of these like advanced stuff in some of the earlier assignment turn-ins, right? Do we have to put those into the test case as well, or is the test case based just on the final output of the program itself?
It's really just based on the final output of the program. Your test case does not need to include invalid user input. So if you expect the user, if you're expecting an integer and the user types in QWERTY, I don't need you to account for that in your test cases.
Copy. Yeah, I wasn't quite sure if the test case was like a cumulative thing, right, of all the different parts of the code, or if it was just that the end result saying if the code needed to output 5 at the end, right? If that was the expected value, that's all we're really worried about, is that expected value being 5, right?
That's correct. I mean, these assignments that you have for this course, they're relatively short, and you generally only have one output at the end that you need to worry about for your test cases. In significantly larger programs, there will be test cases that test out individual sections of your code. It's just not the case with these assignments because they're so short.
Copy. Would it be better off to try to just keep it to the short and sweet of these assignments instead of getting too far off the rails? Because I think I find myself doing that often, where I'm like, well, I really, like the previous guy said, hey, I really want this, so it validates the user input, because I hate it when I accidentally type something in. I'm like, oh shit, my project, oh, I typed premium wrong, or whatever I'm working on. That's, I don't know if that's just a natural thing to make sure it works exactly like you envision it to work. Yeah, I just want to make sure, yeah, if you're saying, hey, look, keep it simple, keep it to exactly what the assignment tells you, then that's what I'll do and probably avoid a lot of extra work throughout the week.
Right. So I would say keep it as long as you fulfill the requirements of the assignment, I would keep it as simple as possible. And I say that because as you add additional features, let's say it that way, if you want to add additional features to your code, that is fine. However, if your additional features break it or cause you to get the incorrect answer, then you're going to lose points for that.
Copy. All right, sounds good.
Good evening, Professor. Can you hear me?
Yep, I got you. Go ahead.
I was wondering if you could, based on your example that you put in, would you be able to kind of combine both the kind of the car and the age into one indented statement?
Yep. So what I could have done is I'll actually show you why I don't like that. I'm not saying you can't. I'm saying why personally I don't like doing that in programming that I do. Okay, so starters, let's take out this checking the input stuff to make it look simpler. So we can say if the kind is fancy and age is less than 24. Let's get rid of the rest of the stuff right now, just so we can see this in action. So we can say if the kind of car is fancy and the age is less than 24, the cost is, I don't remember what I had the cost. The cost is $50. Okay. I can put else if the kind is equal to fancy and age is greater than or equal to 24, and the cost is $25. What else do I need to do though? I got to account for the other things, right? I got to else if the kind is equal to, was it standard, and age is less than 24. Oops, let me put cost equals 25. Cost equals $15. Else if kind is equal to standard and age is greater than or equal to 24, cost is $33, whatever the cost is. Else, maybe if the age is less than 24, that means, it wasn't fancy, it wasn't standard, they mistyped something, but they got the age right, and the cost is $60. Else, oops, forgot my colon there. If it doesn't match any of that stuff, then the cost is $100, whatever the case is. But what's happened here, this has actually become more complicated. It's actually a combinatorial, I think that's the right word. It's like a statistics type thing, combinations, where you have to take into account every single combination. Before, I wish I hadn't erased it now, I just said if kind is fancy, this isn't Python, this is just kind of logically thinking things. Else if kind is standard. And then I had to do if age is less than 24, and I had to do else. And that wasn't else, right? It kind of looked like that, right? Those were the checks I had to do if I separated out, fancy, or separated out the kind and the age. But if I combine them together, altogether that's 3 checks, 4 or 5 checks. But this turned into 1, 2, 3, 4, 5, 6 checks to kind of do the same thing. Now imagine if we had a third option. Let's say, what is beside age we can think of?
Like color of the car?
Yeah, color of car equals, red, or whichever color car is something they type in, right? So now I have to put, if I added it here, I check the kind, I check the age. If color is red, do this, else do this. So now by adding another variable, I've only increased this to 2 additional checks, right? But if I combine them all together, I have to put if kind is fancy and age is less than 24 and, color is red. And then I have to put if kind is fancy and age is less than 24 and color is not red. And then it greatly expands the number of these if-else statements that you have. So for our simple assignments, you can do it like this, and it works reasonably well as long as the number of things you're checking is small. As the number of things you're checking grows, this just becomes unmanageable, and it's best to separate them out. So in my own programming, this is definitely the way to go. In a production environment, if you work for some company, this is going to be what they want to see and not these kind of checks. So this is what I encourage. But if you get the correct answer using this stuff, then I accept that and you'll get points for it.
Thank you.
No problem. So I'll hold on here for another 1 or 2 minutes. If you have any questions, feel free to ask them. If not, feel free to drop off whenever you want. I will have this video uploaded here in a little bit, and then I'll get the link posted on the class page, so you can go back and review it if you want.
Copy. Hey, appreciate it, Professor.